Hi guys, I want to look at the reduction formula for tan. So it's for powers of tan. So what we're going to do in this case is we're going to separate this into tan. So it's a bit different from the one for sin, because for tan we're going to separate it into tan to the power of n minus 2 of x into tan squared of x dx. So what we want to take advantage of here is the identity that relates tan with sec. So that's 1 plus tan squared x equals sec squared x. So what we're going to do is we're going to then change this here into sec. So we know that sec squared of x is equal to, so it's sec squared of x minus 1. That's equal to tan squared of x. So we're going to substitute sec squared of x minus 1 where we have tan squared of x there. So that's going to give us tan to the n of x dx equals the integral of what? Of tan to the n minus 2 of x bracket sec squared of x minus 1 dx. So now what we're going to do is we're going to multiply that bracket with the integral sign, the tan to the n minus 2 of x and the dx. So if we do that, we get the integral of tan to the n of x dx equals the integral of tan to the n minus 2 of x sec squared of x dx, right? So I multiplied this here, what's outside, this part and this part, with this here. So I get that. So it's going to be minus, which is that negative sign, the integral of tan to the n minus 2 of x multiplied by this one here, right? Dx. So that's going to give us something like this. So this part here we can use U substitution, right? So what we will do here is we will say let U equals tan x du will be equal to what? Sec squared x dx, right? So where we have sec squared x dx, we put du. So this part here, we replace it with du. Tan, we replace that with what? With u, right? So that's going to give us the integral of tan to the n of x dx equals, so this part here, let's do it on the side. What we see there is that we get the integral of u to the n minus 2 du. If we integrate that, we are adding 1 to the power, then we are dividing by the resulting power. So that's going to be minus 2 plus 1, then we get minus 1. So it's u to the n minus 1 over n minus 1. So that's going to be tan to the n minus 1 of x over n minus 1, right? So we're going to just put that result, tan to the n minus 1 of x over n minus 1. And then we'll say minus the integral of tan to the n minus 2 of x dx. So that's the reduction formula for tan.